Welcome back. All right, we're going to get right back into the swing of things, and this is the semester where things start to really get fun. Okay, we're going to do chemical reactions and all kinds of other fun stuff as well. In order for us to do everything that we have to do this semester, we have to make sure that we remember these very important things. Okay, number one, we must remember the difference between ionic versus covalent compounds. Okay, ionics, of course, are metal and a non-metal, something like that. And covalent compounds are going to be two or more non-metals. Okay, you got to remember how to name things. Okay, if you don't remember how to name things, go back and take a look at that. That's going to be so extremely important. Don't forget your polyatomic ions. That's extremely important as well. Naming hydrocarbons, all that fun stuff. Okay. So make sure that you remember how to do that stuff. Also naming acids, all that good stuff. Okay. Another extremely important thing to remember is your diatomics. Okay. Don't forget the H7 method. Okay. The H7 method tells us that we start at hydrogen, which is a diatomic. Then we go to the seventh element, which is nitrogen. Okay. And then we're going to draw a 7. So we go to the seventh element, which is nitrogen. Okay, and then we draw a big giant 7 down to iodine, which makes it 7 total elements. Okay, so I've got 1, 2, 3, 4, 5, 6, 7. So HNOFClBr, and I, those are our diatomic elements. So let's go ahead and get into the notes. Okay, first we want to know about counting atoms. So a subscript is the small number to the lower right-hand side of an element. Okay, so when I write a formula like this, when I write out H2O, the 2 is my subscript. Okay, a coefficient is a large number placed in front of a molecule or formula unit. Okay, a formula unit is like an ionic molecule. Okay, if you ever hear me say formula unit, I'm referring to a molecule of the ionic form. Okay, so if I want to say that I've got 3 H2O molecules and I put a 3 out here, this means that, or this number right here is called a coefficient. Okay, this means I have 3 H2O molecules. Okay, so let's go ahead and remember how to write these formulas. Okay, it wants to know how many oxygen atoms are there in a formula unit of iron 3 sulfide. Well, half the battle here is just knowing what iron 3 sulfide is. Okay, so I remember that iron is Fe. Okay, sulfite is SO3 2 minus. Okay, I remember that because I have my polyatomic ions memorized. So I'm going to put SO3 in parentheses here. And since iron has a +3 charge, I know that from the Roman numeral, and SO3 has a -2 charge, I know that I need 2 of these and 3 of these. So this would be my formula for iron 3 sulfide. So I want to know how many oxygen atoms are there. Well, I've got 3 oxygen atoms here, and I've got 3 of those polyatomic ions, so that means I've got a total of 9 oxygens. Okay, so now the question is, well, what if I had 5 formula units of this? Okay, so what that's saying is, what if I put a coefficient of 5 in front of this compound? Okay, now what I've got is I've got the 9 oxygens here, but I've got 5 of this whole situation. So 5 times 9 means that I have 45 oxygens. Okay. How many total atoms are there in 6 formula units of barium chloride dihydrate? So what I'm going to do here is I'm going to write out my formula for barium chloride dihydrate. So I've got Ba, which has a 2+ charge, Cl, which has a -1 charge, so I need 2 of those. And then my dihydrate is 2H2O. And how many total atoms are there in 6 formula units of this? So my 6 is going to distribute out to everything here. So what I want to do is I want to count my atoms. So I've got, assuming that I'm not focusing on the 6 right now, okay? I've got 1 barium, I've got 2 chlorines, I've got 2 times 2 is 4 hydrogens, and I've got 2 times 1 is 2 oxygen. So if I add all this up, 1, 3, 4, 5, 6, 7, 8, 9, I've got 9 total atoms in one formula unit, which means 9 times 6 is 54 total atoms within 6 formula units. Okay, so that's how you're going to do that sort of situation. So now let's take a look at writing and balancing chemical equations. On second thought, we're going to save that for the next video. Like to try to keep them nice and short for you. So, yeah, welcome back, by the way. Glad you're back.